Hello students, I am going to discuss about the concepts of object-oriented programming. First let us try to requirements of a programming language. We want to create new data types. There are data types that are already existing in a programming language, but sometimes the existing data types are not good enough for a particular problem. So for a given problem, we think that none of the existing data types are suitable. So we should be able to create our own data types, that is user defined data types. So there should be provision for the creation of new data types. In C, this has been partially fulfilled by means of structure. So when you create a structure, we are creating a new data type. But in C++, this option has been enhanced and extended, so we can create a full-fledged data type under C++. The next requirement is that when we started writing programs in C, the primary objective of writing programs in C were that either it was for the mathematical problems. So when we have a complex mathematical problem, we can simplify that by writing a program so that the program will solve the problem and will produce a result in a short time. Other domain is writing programs for the hardware. So we write system programs which are running along with the computer hardware. Nowadays we have also started developing programs for the applications, business applications. For example, we have software running in banks, in insurance companies, in railway reservation. So those kind of applications are termed as business applications. There the C language is not sufficient. So we need a way to represent real life entities in the sense we want to represent people, money, a company, so many other things which are encountered in a business, they have to be represented in the programs. So we don't have a mechanism for that in C, and that has to be provided by the object oriented concepts. The next one is reusability and extensibility. In C there is a limited option for reusability by means of functions. So when you write a function, you can reuse a function again in another program if the requirement is same. But beyond that there is no other reusability available in C. But we will see that in object oriented programming under C++, the reusability can be further extended. It can be done at a much larger scale. So reusability is the next requirement which we are going to expect and get fulfilled from OOPS. The next one is tolerance to changes. So we write a program today and some change is needed in future. So when you make any change anywhere in the program, then the entire program has to be updated. So that is a difficulty with changes. So we need a mechanism by which if you change somewhere, you don't need to change everywhere. So that what we are referring as tolerant to changes. So we need that also to be available. The next one is avoiding complexity. So programming is in general a very complex process. We have a lot of complex logics involved in programs. But these complexity should not affect the user. The user should be able to see a simple interface without realizing how complex the logic behind it, and he should be able to use it with his limited knowledge. So hiding complexity is another requirement. And the next one is protection and restricted access. So when you write C programs, there is no protection available. Anything can access anything. So any data can be accessed by any function. But as we are getting into business applications, restriction becomes important. So some data has to be restricted so that only some people can access and remaining people should not be able to access. So we have to enforce restriction on the data that has to be provided by OOPS. Let us go into the requirements in detail. So first we highlighted that there is a need for creation of new data types. So look at this example. In this example, the user can select any one of the colors that are shown on the screen. But what if none of the colors suits him? Let us say for my purpose, I have a different color in mind which I am not able to see anywhere. In that case, I am getting a different option that I can create my own custom color. So similarly, while we write programs, when the existing data types are not suitable for our purpose, we should be able to generate a new data type. That is what we mean by creation of new data types, which is a important goal. Another is hiding complexity. Just observe this example. What you are seeing in front is nothing but a mobile phone, but we don't use a mobile phone by learning this complexity, because we are provided a simple interface. So this interface hides the complexity behind it. As a result, any person can use a mobile phone without the knowledge of the complexity behind it. So similarly, while we develop applications, the application should hide the complexity of its background logic from the ordinary user. So hiding complexity is what is an idea we are getting from this. These are examples of real-time entities. For example, you are trying to write a program for some human resource application, which means you have to represent human beings. So you have to represent people based on their gender, like that. So in that case, we have to represent human beings. Similarly, you have to represent an airplane if you are trying to write a airplane reservation application, or you may have to represent a car, a train, a hospital, or even a government, money, any electrical equipment. So when you are writing different applications, depending upon the type of application, you may have to deal with the different entities. So your program should be capable of representing those entities. So in that case, we need to go for object oriented programming languages, because OOPS provides a mechanism by which we can easily represent the real-time entities. The next requirement is reusability. So try to understand what do we mean by reusability from this example. So a typical process involved in a production of a new car is that first it has to be designed. So there is a team which has to work out on the design of the new car, and it has to be verified, approved, then it can go for production. And this is a tedious process. Both the time and money is involved behind it. One simple way of reducing this is that they can use the existing model and then can make changes and produce a new design. For example, in this example, it's nothing but a Swift car which is already designed and produced. Now if the company wants to produce an SUV kind of a car, they don't have to redesign the whole thing. They take the Swift model, make changes and make it into a SUV. Similarly, they can produce a sedan design out of the Swift design. So this is an example of reusability. What is the benefit of reusability is that you save the time, because you are not starting from the beginning, and you also save the time, money. You don't have to spend a lot of money in redesigning a new design. That is the idea of reusability. Access control is about providing restricting access. As I told you, the usage of object oriented programming is more for business applications where many times money is being handled. So let us say we write a program for a banking application. So in that case, the bank has to provide protection of the money. So not everybody should be able to access everybody's account. An account has to be accessed only by the owner of the account, not by others. So there is a need for access control. That's what is represented by these examples. There is no such mechanism of access control available in C, but we will see shortly how we can provide access control under C++ with the help of OOPS concept. Before getting into the OOPS concepts, let us also try to go into the history of programming languages, how the programming languages evolved, starting from machine language. See, the basic idea behind the evolution is the reducing of the complexity. So managing complexity is the driving force behind evolution. So people started to develop machine programs in the beginning, But then when they started more larger programs and complex programs, they could not manage with the machine language, and that made them to switch to assembly language, which was relatively easier. But even that was that started became difficult when the size of the program and the complexity of the big program gets larger. And finally they reached the machine high level language program, and that was the most convenient way of writing a program. So we can write the entire program in high level language in English statements, so which we can easily understand and develop. The high level language programs, programming languages can be classified into three categories. The first category is called procedural languages. Procedural languages are nothing but languages which consist of procedures, which are same as functions. So when you can write programs with the functions, they are termed as procedural languages. There are examples like Pascal, Fortran, COBOL. These were procedural languages. The next language that came was structured language. A structured language is a procedure language, but it also consists of control structures. So we can divert the flow of execution using conditional statements, like we can use an if condition with the else part, or you can use loop statement. So these control structures are added into the procedural languages. So now the programs can have both the functions, and the functions can have control structures. And we have the example of C, C++, Java. Ultimately we have reached the OOPS era. Under OOPS, the language is procedural, structured, and also object oriented. So we can add the concepts of OOPS into the programming languages. Those languages are termed as OOPS languages. Examples are Java and C++. The fundamental difference between OOPS and the previous, that is structured language, is that in the structured languages, it was the data that was central point. So the entire program was around the code. What code you are writing is the primary objective. But in the object oriented programming, the data is the central focus. So how do you manipulate data? What functions you have to manipulate data? How do you protect the data? So it's all everything about the data. It's something like during the king's rule, it was about the kings, not about the people. So as for the instructions of the king, as for the wish of the king, the people have to act. Whereas in the case of a democratic system which you are following currently, it's the people that were controlling the government. So the government has to act as for the needs of the people. Similarly, in the structured programming, code was controlling the program, but now data is controlling the program. So the code is written to handle the data. You can understand that point from this diagram also. So here we have data at the center, and we write three functions to manipulate the data. This is a summary of the differences between procedural and object oriented languages. So procedural languages consist of functions, and object oriented languages consist of functions along with the objects. And it is procedural languages are top down, and this one is bottom up, and there is no access specifier, which means we can't control access in procedural programming, whereas we can control who can access the data by setting the access specifier as private, public, or protected under object oriented programming. And we can't create any new data type under procedural languages, but we can create data types, our own data type in OOPS. And there the functions are important, but here the data is important, and there is no good mechanism for representing real world entities under procedural programming, but we have got objects. Objects can be used effectively for representing the real world entities under OOPS. So we are now going to explore the concepts of object oriented programming. These are said to be the five concepts of OOPS: objects, class, inheritance, polymorphism, abstraction, and encapsulation. Let us try to understand each one. The first and the most important concept of OOPS is the creation of objects. So object is the central point. It's like the brick in a building. So it's on top of the brick only the entire foundation. We can treat it as like foundation. So objects are nothing but the real world entities represented in the program. So when you write a program for a particular domain, whichever entity involved in that particular domain, they all will be represented as objects. And every object will have characteristics and functionalities. You will see some example of that. So an object means it will have two things. One is attributes, which are nothing but characteristics or values. Other one is its activities or functions. So we will be combining these two to construct a object. And objects also allow us to conceal data. So we have seen earlier that protection is needed. So we can now protect the data which are hidden into the objects. We can set the access specifier of any object by using the different access specifiers as private, protected, and public. And as just now I mentioned that an object has two attributes, two members. One is its attributes and its functions. So which are nothing but the variables. So we can declare variables in an object which are referred to as the data members, and we can also define functions into the objects which we are going to refer them as member functions or methods. These functions are actually meant for manipulating these variables. For example, if you take the object of a student, let us say I am trying to write a program for student result manipulation. So I need to represent a student. In that case, my object is about student, and the data members will consist of the student register number, name, gender, date of birth, class, etc. We can add any such attribute that is required for our purpose. And the member functions may include writing exam, attending class, submit. These are the activities of a student which can be treated as the functions. But once we have defined an object consisting of only these data members and these member functions, we can't add any other member into the class, or nobody else can add anything into the object which is already constructed. So for example, into this object it's not possible to add watching films because it's already processed. So once it is processed and produced, no change can be made into an object. This provides a strict maintenance of the object. That object will remain intact with no external interference or manipulation. As we just saw, an object is a fundamental building block of a object-oriented programming. But then how do you create it? So to create an object, we need a template or a designed format through which we can create a new object. So class is the template for creating an object. If you have designed, if you have conceived an object, then you have to express it to the compiler. You have to express that this is the way I want to create my new object. And class is the mechanism by which we express the requirement of a new object. So once you define a class properly, then the compiler is ready to help you in creating any number of objects. So based on the class, you can create objects. An object can be treated as like a blueprint of a building. So once when you want to construct a new building, the first step is you have to create a blueprint, and that blueprint will later be converted into a building. The same way, you define a class first and you construct a object using that. We can also say that an object is an instance of a class. So what do we mean by an instance is that a class is a design, not a real entity. When you create a real entity out of it, we call it as an object. This process is called instantiation. So instantiation is creation of object with the help of a class. object is a implementation of a class. Now let us try to explore the other concepts of object oriented programming. Inheritance. So inheritance, as we have already seen, reusability. So inheritance is the concept that facilitates reusability and extensibility. So it allows us to create classes which are treated as is a type of relationship. For example, we create the Swift class and then we inherit it by the Desire class and the Ertiga class, so that whatever is there in the Swift class will automatically become part of the Desire class. So the Desire class will only include the additional members. Whatever is new for this new second class, that alone needs to be included. The existing members need not be repeated. Similarly, we do the same for the Ertiga class. The Ertiga is a Swift and it is also having its own unique features. This is the basis of inheritance. So whatever the existing class, we can use it for creating the new classes without rewriting everything again. This is another example where we have a shape class. The shape class will include all the common members of a shape, and when you go into triangle, we will differentiate. So we will add the unique members of a triangle, and similarly we can do the same for the other shapes. The next concept of OOPS is polymorphism. Try to understand the idea behind it through this example. Let us say we have got three different electronic items. One is an AC, a set-top box and a television. A problem with having too many electronic items is that we have to maintain that many remotes. For each one we have to have a separate remote, and that becomes a tedious task. One is we have to remember the remote for each. So if you try to use the AC remote for a television, it won't work. So you should be very careful in not using the wrong remote control for a particular item, and that is a burden. So to overcome that, there is a solution in the name of universal remote. The idea behind a universal remote is that it's a single remote control which has the functionalities for different devices. So if you are holding it against a television, automatically it will act as a television remote and you can change the channels, whereas if you put it against the AC, you can use it for reducing the temperature, so it will act accordingly. So one solution, but it will act differently without bothering the user. So user need not have to think to use the specific remote. The remote will take care of the usage. This idea is called polymorphism. So one interface, but it will act differently depending upon the situation. Another popular example is a flask. A flask is capable of holding something hot or something cold. So what you put inside a flask will determine whether the flask has to act as a heater, so that it heats it keeps the temperature, or if you put a cold water into the flask, then it will try to keep the cold in cold temperature. So what you put inside will make the flask to operate. Now moving to the next concept, it's called abstraction. Abstraction is actually the implementation of the hiding complexity. So we hide complexity through abstraction, and because the abstraction is available under object oriented programming, we no longer need to reveal the complexity of anything. The user will only get to see a simple interface, and he never needs to know about the complexity behind it. The next concept of OOPS is encapsulation. So under encapsulation, we try to combine many things into one entity. For example, if you look at a capsule, okay, a capsule is nothing but when different medicines have to be combinedly given, then the best option is using a capsule. So a tablet is only useful when you have a single medicine, but when you have too many medicines to be served to the patient, then they all can be put together inside a capsule, and the patient will only take a single capsule without realizing that there are so many things inside it. Similarly, in this example, we have a locker. If you open the locker, there are lot of things. So we are able to encapsulate or conceal many things into one enclosure. So encapsulation is used to hide the values preventing external unauthorized access. So it is actually encapsulation that provides the security or access control. So to summarize, OOPS concepts are added to C to enhance its capability to manage complex problems. And OOPS based languages are good to represent real world entities, to facilitate reusability, and to provide access control. C with the OOPS is nothing but C++. Object is a fundamental element of OOPS through which the various OOPS concepts are implemented. So these are the various points you would have understood from this video lecture. We will later see how we can make use of the OOPS concepts while writing programs. We just have conceptually discussed the object oriented programming concepts, and next we will discuss about the implementation.